Golden wheat fields ripple under sunlight, signaling maturity as grains reach optimal dryness for efficient harvesting and high-quality flour production. Each wheat head holds tightly packed kernels, their color and firmness indicating readiness for harvest and consistent milling performance.
Modern combine harvesters cut and collect wheat efficiently, separating grain from stalks while maintaining speed, precision, and minimal field loss.
Inside the harvester, threshing systems separate kernels from husks, ensuring clean grain collection while minimizing waste and preserving grain integrity. Freshly harvested wheat flows into transport trucks, forming uniform loads prepared for rapid delivery to nearby grain processing facilities. Grain transport begins immediately, with loaded trucks moving efficiently from fields to processing centers to maintain freshness and prevent moisture exposure. Collection facilities, wheat is unloaded into intake systems, where it begins its transition from raw harvest to controlled industrial processing. Conveyor systems transport wheat through enclosed channels, directing grain efficiently into storage silos while protecting it from contamination and environmental exposure. Stored in massive silos, wheat remains protected and stable, ready for the next stage where it will be cleaned and milled into flour. Raw wheat enters cleaning systems where vibrations and airflow remove impurities, preparing grains for precise and hygienic milling operations.
Airflow systems extract lighter impurities, ensuring only dense, high-quality wheat kernels continue toward the next stage of processing.
Magnetic filters remove microscopic metal particles, protecting milling equipment and ensuring the purity of flour used in cracker production. Conditioning adds controlled moisture to wheat, softening outer layers and optimizing kernel structure for efficient and consistent milling performance. Resting periods allow moisture to distribute evenly, ensuring each kernel reaches the ideal condition for precise separation during milling. Roller mills break wheat into smaller components, separating bran and germ while beginning the transformation into fine flour. Successive milling stages refine particles, gradually producing consistent flour while separating coarse materials through precise sifting and grading systems. Fine flour passes through precision sifters, achieving uniform particle size essential for consistent dough formation and cracker texture. Pneumatic systems transport flour efficiently through sealed pipelines, maintaining cleanliness while delivering it directly to controlled storage units. Stored in controlled silos, refined flour remains stable and ready, forming the essential base ingredient for saltine cracker dough preparation. Precisely measured flour descends into mixers, forming the foundation of dough, where consistency and proportion define the final cracker texture. Water, yeast, and dissolved salt are introduced in controlled ratios, activating the transformation from dry flour into cohesive dough. Mixing begins as rotating blades combine ingredients, gradually forming a rough dough with uneven textures and initial gluten development. Continued mixing develops gluten structure, transforming the mixture into a cohesive, elastic dough with increasing strength and uniformity. Yeast activates within the dough, producing gas that initiates fermentation and begins building the light structure essential for cracker texture. Temperature control ensures ideal conditions for yeast activity, balancing heat and moisture to support consistent fermentation and dough quality.
Once fully developed, the dough is released with a smooth, elastic consistency, ready for controlled resting and fermentation progression.
Dough moves steadily toward resting areas, where controlled conditions allow fermentation to deepen and structure to stabilize. Dough is placed into fermentation bins, where time and controlled conditions allow yeast activity to expand internal structure evenly.
As fermentation progresses, the dough slowly expands, developing internal air pockets that will influence the final cracker texture.
Dough rests in controlled chambers, where stable temperature and humidity allow yeast to activate and begin structured fermentation. Small air pockets begin forming as yeast releases gas, initiating the internal structure that defines the cracker's layered texture. Inside the dough, gas expands gradually, stretching gluten networks and creating a balanced internal structure essential for proper baking performance. Sensors continuously monitor conditions, adjusting temperature and humidity to maintain precise fermentation and consistent dough development. Over time, the dough rises steadily, its volume increasing as fermentation progresses and internal pressure builds evenly.
Dough elasticity is carefully checked, ensuring it responds correctly to pressure and has reached optimal fermentation readiness.
Gas release stabilizes internal pressure, preventing overexpansion and maintaining the balance required for uniform cracker structure. Once fermentation is complete, the dough is carefully transferred for further processing, preserving its developed structure and elasticity. The fermented dough advances toward rolling systems, where it will be flattened into precise sheets for cracker formation.
Fermented dough enters rolling systems, where controlled pressure begins flattening it into a uniform sheet for precise shaping.
Initial compression reduces thickness, transforming the soft dough into a more consistent sheet while preserving its internal structure. Successive rollers refine the dough further, gradually achieving precise thickness through controlled, step-by-step compression and extension. Surface texture smooths as air pockets redistribute, creating a uniform structure essential for even baking and consistent cracker appearance. Sensors monitor thickness in real time, allowing automated adjustments that ensure every section meets strict dimensional standards. The dough sheet extends across conveyors, maintaining consistent width and thickness as it advances toward shaping and cutting stages. Final rollers achieve the exact thickness required, ensuring the dough is evenly prepared for cutting into uniform cracker shapes. Edge trimming removes irregular sections, maintaining uniformity, while excess dough is efficiently recycled back into the system. The calibrated dough sheet advances smoothly, fully prepared for docking, where precise perforations will control its baking behavior. The refined dough sheet moves toward docking systems, where controlled perforations will regulate airflow and prevent uneven puffing during baking. Docking rollers create uniform perforations, allowing steam to escape evenly and ensuring crackers bake flat with controlled structure. Each perforation is carefully spaced, forming a pattern that directly influences texture, crispness, and structural integrity during baking.
Multiple docking rollers operate together, ensuring consistent perforation across the entire sheet without disrupting the production flow.
Perforations release trapped air, stabilizing the dough and preventing unwanted bubbling during high-temperature baking. Surface brushing removes excess flour and debris, ensuring a clean, even finish before the dough advances to cutting. A fine mist conditions the surface, improving texture and preparing the dough for consistent seasoning application after baking. With docking complete, the prepared dough sheet continues forward, ready for precision cutting into uniform cracker shapes. The perforated dough sheet enters cutting systems, where precise shaping defines the final size and form of each cracker. Rotary cutters stamp uniform shapes into the dough, ensuring each cracker maintains consistent dimensions and alignment across the sheet. Each cracker shape forms with clean edges and centered perforations, ensuring even baking and a uniform finished appearance. Multiple cutters work in unison, shaping the entire dough sheet into a continuous grid of evenly spaced crackers. Excess dough is removed efficiently, leaving behind neatly formed crackers, while unused material is recycled back into production. Crackers align in precise rows, maintaining spacing that ensures uniform heat exposure during the baking process. Controlled vibrations stabilize positioning, ensuring each cracker remains properly aligned before entering high-temperature ovens. Precisely cut dough pieces advance toward baking, where heat will transform their structure into crisp, golden crackers. The dough enters high-temperature ovens, where controlled heat begins transforming moisture and structure into crisp cracker layers. Inside the oven, multiple heat zones regulate temperature precisely, ensuring even baking while initiating controlled expansion within each cracker. Heat activates trapped gases, causing slight puffing that creates the signature layered texture within each cracker. Moisture evaporates steadily, drying the dough and forming the crisp structure essential for long shelf life and satisfying texture. As baking progresses, the crackers develop a light golden color, signaling proper heat exposure and balanced internal cooking. Temperature systems continuously adjust heat levels, ensuring consistent baking conditions and preventing overcooking or uneven coloration. Near the oven exit, crackers reach full structure, with balanced crispness and uniform color achieved through controlled heat reduction. Freshly baked crackers exit the oven, retaining heat as they transition into cooling systems that stabilize their final texture. Warm crackers advance toward seasoning systems, where surface preparation allows salt to adhere evenly across each piece. Measured salt is dispensed evenly, ensuring each cracker receives a consistent layer without excess or uneven distribution. Salt crystals settle across the surface, adhering to the warm texture and creating the signature flavor and visual appeal. Multiple lanes are seasoned simultaneously, maintaining uniform salt distribution across large-scale production without interrupting flow. Controlled air systems remove excess salt, ensuring balanced seasoning while preventing waste and maintaining consistent product quality. The finished surface reveals a crisp texture with evenly distributed salt, defining the classic appearance of saltine crackers. Seasoned crackers proceed to extended cooling, where airflow stabilizes texture and prepares them for handling and packaging.
Air circulation systems regulate cooling, ensuring each cracker reaches a stable temperature without compromising its crisp structure.
With seasoning complete, the crackers move forward fully formed, ready for inspection and final quality assurance checks. Crackers move along extended cooling lines, where airflow gradually reduces temperature and stabilizes their crisp internal structure. High-capacity fans circulate air evenly, ensuring consistent cooling across all crackers without disturbing their alignment or surface seasoning. As heat dissipates, the internal structure firms, locking in crispness and preserving the delicate layered texture formed during baking. Thermal sensors monitor temperature across the conveyor, ensuring each cracker cools evenly before advancing to inspection and packaging. Multi-level conveyors extend cooling duration, allowing efficient temperature reduction without slowing production speed or disrupting flow. Cooling completes structural stabilization, with slight contraction enhancing firmness and ensuring each cracker achieves its final crisp consistency. Fully cooled crackers exit the system, now stable, crisp, and ready for detailed inspection before packaging. With cooling complete, each cracker maintains uniform appearance and structure, meeting the standards required for final quality assessment. Cooled crackers enter inspection systems, where advanced imaging technology evaluates each piece for uniformity and quality compliance. High-speed cameras analyze surface details, detecting imperfections such as uneven color, cracks, or inconsistent salt application. Intelligent systems instantly identify defects, ensuring only crackers meeting strict quality standards continue through the production line. Automated sorting mechanisms remove defective pieces with precision, maintaining efficiency while preserving product consistency.
Weight control systems verify each batch, ensuring consistent portioning and compliance with packaging standards.
Human inspection adds an additional layer of quality assurance, verifying texture and appearance beyond automated detection systems. Approved crackers proceed seamlessly, meeting all quality benchmarks and ready for packaging without further modification. Rejected crackers are collected separately, allowing recycling processes to reduce waste and maintain production efficiency. Final checks confirm product consistency, allowing only fully compliant crackers to move forward into automated packaging operations. Approved crackers enter packaging systems where speed and precision ensure protection, freshness, and consistent product presentation. Crackers are grouped into precise stacks, ensuring consistent portion sizes and maintaining structural integrity during packaging. Protective film wraps around each stack, forming a sealed barrier that preserves freshness and protects the crackers from external moisture. Heat sealing bonds the packaging material, creating airtight protection that extends shelf life and maintains product quality. Branding and product information are applied, ensuring each package meets labeling standards and is ready for retail display. Packaged crackers are organized into cartons, preparing them for efficient transport and large-scale distribution. Cartons are sealed and labeled, enabling tracking, inventory management, and smooth logistics throughout the distribution network. Cartons are stacked onto pallets, forming stable loads ready for storage and transportation across supply chains.
Pallets are wrapped securely, protecting products during transit and ensuring stability throughout handling and delivery stages.
Finished pallets move into distribution warehouses, where organized storage ensures efficient handling and readiness for shipment. Pallets are placed into storage racks, maximizing space while maintaining accessibility for rapid order fulfillment and logistics coordination. Digital systems track every pallet, ensuring accurate inventory management and efficient coordination of outgoing shipments. Pallets are loaded into transport trucks, secured carefully to ensure safe delivery across regional and national distribution routes.
Transport vehicles carry products across long distances, linking manufacturing facilities with distribution centers and retail locations.
At regional centers, shipments are received and sorted, preparing products for final delivery to individual retail stores. In retail stores, employees stock shelves, making the finished crackers accessible to consumers in organized and visible displays.
Packaged crackers sit ready for purchase, their journey complete, from raw wheat fields to finished product on store shelves.
The final step connects production to consumption, as customers select the product shaped by a precise and continuous industrial process.